In this video, we're going to talk a bit more about the effect of the k and m values on the equation of a straight line. So, or the meaning of the gradient and y-intercept. Another way of saying this is the effect of the k and m values on the graph of a straight line. So we are going to do a bit of investigation here, and I'm going to use a program called GeoGebra, which you may or may well not have heard of. I think I introduced this in a previous video. What we're just going to do is I'm going to plot three different functions on the same window. So the first function is going to be x plus 4. There we have it, the green one. Enter. G is going to be x plus 2. Enter. Red. And H is going to be x minus 1. There we have it. Let's just grab this and copy it into my other window. Let's create a new slide. Paste it in. So let's analyze these three graphs. So if we look at, let's use the same color. This is f was equal to, these are all functions, remember. F of x, which is equal to y, is equal to x plus 4. So our m value, or rather our k value, our gradient is 1, but m is equal to 4. This number here, the constant term here. In this graph, y is equal to x plus 2. So our gradient is still equal to 1. But our m value is equal to 2 this time and not 4. In the final example, this graph has the equation y equals x minus 1. So the equation of the straight line here has gradient 1, but m value minus 1. Well, they all have the same gradient, so they all have the same slope going upwards like this. But what's the effect of the m value on the graph? Well, they all intersect the y-axis at different values. This is my x and this is my y. So the meaning of the m value is where the line intersects the y-axis, or it's called, that's the meaning of the y-intercept. So the m value gives the y value where the graph intersects the y-axis. And this is the definition of, this is called the y-intercept. And the coordinates are 0 on the x, comma, m. This is important to remember. Right, let's open up my GeoGebra window again, and let's look at a couple of other graphs. Let's delete these. Let's just hide them. Let's add two more functions. Let's call one I equals 2x plus 1. That was something else. Okay, j of x. j of x equals 2x plus 1, the orange curve there, and y or k of x equals minus 3x plus 7. Just going to have to zoom out one step, 2 steps, move my window down like this. Well, these two lines have different gradients. What's different about them? Well, this red-orange one here slopes upwards from the bottom left-hand corner to the top right-hand corner. And this one slopes downwards from the top left to the bottom right. Let's grab this one and paste it into my other window. Let's take a new slide. Make it bigger so we can all see it. So this line had the equation y equals 2x plus 1, change colour, and this one had equation y equals minus 3x plus 7. Well, we've already just learnt that the m value gives us the y-intercept where it goes to the y-axis. But what's the effect of this number here? Well, we have k equals positive 2 here. It means that we have a slope, a positive slope going up from the bottom left to the top right. And it means that for every one step we take in the x, we go up 2 on the y. That's the meaning of the gradient. If I make this a bit better. So if I go from 0 to 1 here, if I go along 1 on the x, I should go up 2 in the y, so I should end up here at y equals 3. If I do one more step, if I go along 1 more on the y, I get to x, if I go 1 more on the x, I get to x equals 2, and up another 2 there on the y, I should get to y equals 5, and so on, increasing 2 steps in the y for every 1 step on the x. And this straight line here the blue one, has a negative gradient. This red one has a positive gradient, this one has a negative gradient. It slopes downwards from the top left. And the -3 here, that means for one step on the x, I go down 3 steps on the y. So if I start from -1 here, if I go along 1 on the y here, I go down 3, and I start at y equals 10 rather, when x equals -1. However, if I go along 1 on the x here, I go down 3 on the y and end up at y equals 7. So in general, what does the effect of the x coefficient or the gradient have on the line, the appearance of the line? Let's just summarize this. In a new slide. So we have 3 different cases. So when the straight line looks like this, we have a positive gradient, so the k value is greater than 0. We'll talk about positive gradients. When the straight line looks like this, the k value is less than 0. We talk about negative gradients. And when we have a horizontal line, the k value is 0. We have 0.